going on. So because of that reason, we'll be doing like some Wireshark stuff, and I'll be using this setup. So what I have is just it's GNS3 mixed with VirtualBox, and you don't have to do your own test environment this way. The reason why I've just decided to do my own this way is because I found out that it's easier if people can see a visual that they can relate to. So you see a visual where you can see the actual devices connecting to switches, or if they're connecting to routers and stuff like that. And then the other good thing about having this kind of setup is I can go across this link and capture the traffic across this link, and then it just makes things much more easier in a class environment. You can accomplish the same thing like with VirtualBox and VMware, only that you have to install Wireshark on on all your machines and stuff like that. But this one, once you connect the link, I could just go, for example, I think I'm currently capturing traffic here. I could just go start capture here, and we can see instantly what traffic is going on between this machine. We can filter whatever we need to filter and stuff like that. So yeah, so let's start. Um, yeah. So stop and quit. Okay. Um, let's bring up the page. So first thing that I want to discuss is is the dynamic DNS update. So DHCP and dynamic DNS update. So if I bring that up from the page here. So because here's one of the things that I've seen that people have found a bit difficult to understand is what's like the normal behavior of DHCP dynamic DNS update. How does that work? What actually is going on in terms of updating DNS records? So I'm sure we already know the basics because the basics are basically your machine gets a DHCP address from a DHCP server. After getting a DHCP address from a DHCP server, um, it needs to be registered in DNS. So how does that registration in DNS, how does it happen? What are the processes to protect that? So does anyone wants to describe like what the what the normal behavior is? So for bring. So starting from scratch actually. Let's go back to this one. So this server 3 here, or this server here, I can actually just change it from server 3. Let's call it DHCP server. It'll be DHCP, and this is just a domain controller. Maybe C1, and then this is a Windows 10 machine, a Windows 8.1 machine, a Linux machine, so we can test the behavior of that, and then you see some of the random things that we saw that occurred. So first thing I'll do is I'll get rid of DHCP on this machine. And let's get rid of that, and then we'll start from scratch. So why it's doing that, okay, so yeah, just DHCP and DNS dynamic update. So what's the normal behavior that happens when you have just normal basic DHCP DNS dynamic update working? So on your machine, let's say you have a machine here, which is a normal Windows machine. You have a normal Linux machine here. So this Windows machine is not joined to the domain. And same thing as this Linux machine is not joined to the domain. I will just call this Win client 1 Linux client 1, and in your environment, you have a DHCP server on the network. It's kind of like a similar setup, and you have a DNS server on the network. So you have a DHCP server that gives addresses out, and you have a DNS server that hosts all your namespace, your zones, and all that. So this machine comes on the network. It comes on the network. It contacts the DHCP server and gets. So again, remember it's not joined to the domain, and gets an IP address. So comes on the network, requests an IP address from this DHCP server. DHCP server responds and gives it an IP address. Now this machine has this name. Now it has an IP address. How will registration occur by default? So right now you've installed just basic default settings. How will registration occur for the name of this machine and its IP address in DNS? Who wants to go for that? Just your own understanding of it. So Vincent, do you want to go, or Sven, do you want to go first for that? So what would be the normal standard behavior for that? Vincent, do you want to go for that? Because it will be good to know what you think about that, what your understanding is on that. Okay. Yeah. Okay, what about Sven? You want to go for that? What's your understanding of that?
No, my problem is that the client doesn't have an information about the zone. So it will be a problem for the DNS server to register the client for a special zone.
So in this case, so this machine not joined to the domain.
Yeah, because
yeah.
So normally I would say, okay, it just registers the name in the domain zone, like corp.local or stuff like that. But now the client isn't joined to the domain.
Yeah. Good one. So I mean, so at the end of the day, what do you expect to see in DNS? Do you expect so on this DNS you have a zone for, let's say, this whole entire network domain is called test.com.
Yes.
And the pointer record is 192.168.129.0/24. That's the pointer. Yeah. So will you expect to find a record in test.com for this client?
Yeah, perhaps that's the information that the DHCP server is giving to the client, and so the client knows, or the DHCP server does a registration for the client for the zone. I guess it's like that.
So what's the normal behavior? So okay, right now, so what I'm trying to get, okay, so right now, what would be the normal behavior? So this machine has received the DHCP address from this one. What would be the normal standard behavior? Who would try to register which record? So this yeah.
Whoa. So yeah. Okay. So one possibility is that the client registers its name in the DNS server. Other possibility would be that the DHCP server does a registration for the client. So, but what's the default behavior? So, I guess the client does a registration on the DNS server side could be the default behavior. So this is my guess.
Yeah.
But I'm not quite sure about this.
Yeah. No. I actually you have really close, like in like what you've described, because the first thing you mentioned is absolutely right in terms of now the client has no knowledge of the zone.
Yes.
So it's not joined to the domain. In other words, the normal behavior or the default behavior for a Windows machine. So we'll come to Linux later, and you see some weird behaviors that even the ones that are documented by Microsoft that are supposed to work don't work. At least in the test that I've done, maybe something is wrong in the lab, but there are some behaviors that Microsoft documented and said this is the way it should work, or that you see on internet articles and said this is the way it should work on Linux, but I don't see that work. So, like in this situation, the normal behavior is the client gets an IP address from DHCP server, Windows client, the client will request for the DHCP server to do a pointer record registration. So in other words, by default, out of the box, by default, a Windows client gets an IP address from a DHCP server and tells the DHCP server to register the pointer record here. So you won't be surprised if, even though this machine is not joined to the domain, this pointer record of this machine, you may still find it in the domain here because that's been handled by the DHCP server. So you find it under here. But by
Okay.
default, the Windows client would try to register its own name in DNS. And in
Okay.
which case, what will happen is it will fail. Because like you said, number one, it doesn't even have any knowledge of the zone. So which zone am I going to put you in if I have lots of zones here? So
Yeah.
except the network adapter of this machine has been configured with a DNS suffix. So except we've specifically said in a machine that's not joined to the domain, we've specifically gone under the network adapter and said and configured this setting to say um, this is your DNS suffix and use this DNS suffix whenever you want to register. So under advanced
Yeah.
here, so you can go on the DNS and except we've gone and said, okay, register this connections address in DNS. And we'll put the DNS suffix here and say the DNS suffix to use is test.com. And we say use this connections DNS suffix in DNS registration. Then it knows which zone to try to tell the server to register it in. So it's like, hey, DNS server, can you give me the SOA record for and this zone, test.com? So then that server replies, then it says, okay, SOA record DNS server for test.com, can you register me in your DNS? But even though with this, by default, this will still fail. So by default, even though the client is configured with test.com here, by default, this will still fail. Does anyone know why it will fail by default? I don't know why.
Um,
Yeah.
um, I guess because we are using integrated zones, are you using Active Directory integrated zones?
Yep. And
Okay.
by default, except you change the
And
default settings, it's configured for name protection.
uh,
And what does name protection mean? Name protection simply means it needs to be authenticated. So if you come and say, I want to register a record in this zone, it's going to ask you. So it's going to ask you to do Kerberos authentication. So you have to get your token ready and be able to authenticate. But then this client doesn't have a token, so that will fail. So let's see that standard normal behavior first of all. So let's bring up this one here. So right now I just have this domain controller. Again, this is the setup. Domain controller, DHCP server, 3 different clients. Um, let's bring up, let's install DHCP on this one. We already know how to install DHCP, but let's just go and install DHCP here. Where we manage, just quickly add roles and features. Select DHCP, install all the other features, next, and install. And while it's doing that, I'll go quickly to the domain controller. If I go on the here, so because there's something I want to that is good to point out here. So Active Directory sites and services. Let's bring that up and go on the site here. Actually, we have to go on the view action. Is the action of view? So, because I'm not seeing services here. Okay, yeah, we need to go on the show services node, and then on the services node, um, on the net services. So actually, if I delete this one, because that's not there by default. So I'm currently installing DHCP on server 3. Now it's finished installing. I click close. I go up here. I click complete DHCP registration. Now, first thing it tells me is, hey, after completing this registration, you have to To complete it, you have to do some other setup, some post installation setup. You have DHCP said, I'm going to create the following groups: DHCP administrators and DHCP users. And I'm going to authorize this DHCP server on the target computer. So now what that means is any machine that's joined to a domain, any Windows Server machine that's joined to a domain, and you install DHCP services on it, DHCP server services will not function on that machine except it's authorized in the domain that it's joined to. And I'll show you what the authorization does, which is why I went to delete the other record previously. So it says I'm going to create the following groups for delegation: DHCP administrators, DHCP users. Okay, no problems. Go next. Um, I'm going to use the following user credentials for the authorization. So it's going to use my admin credentials. Now, an important thing to note is that the only account by default that can authorize a DHCP server are domain admins and enterprise admins. Those are the only account by default that can authorize a DHCP server in a domain, and you can find that. So there's a way for us to delegate that if we want to, but by default, those are the only accounts. Going back to this one, if I click commit on that, and it said it's done, yeah, and then we close that. So going back to the domain controller. Now what I've done is open Active Directory sites and services, right? I opened Active Directory sites and services. I went under view. I went under view. So let me close this again actually, just to show you the thing that I've done so far. So close this window, open this. It'll probably show up now. So go under Active Directory site and services. So this services node is not there by default. You have to go under view, and there's an option that you find here that says show services node. So you click on that option to show services node. And now you have the services node there, and then you can see all the different services. So things like RAS, if you have radio services, they will be listed here. And under net services, there we go, we have server tray. So that's basically what it's doing with the authorization. It's creating an object with the class DHCP class for your DHCP server, and it's putting it under this node. So that's basically the authorization. If I delete this server is no longer authorized for DHCP services in this domain. So that's like just to understand, like when it says, "Oh, I'm authorizing you," what's it doing? That's what it's doing. It's just simply adding this object with this class, with the DHCP class under here. And if you go under Active Directory Site and Services, under Net Services, you can see all the DHCP, all the servers that are authorized for DHCP services in your domain listed here. Okay. So after getting the other one that I've seen people mention about is, okay, it says it's going to create DHCP servers and DHCP administrators. So then people go on the domain and go on the, well, it's created, it said I've created DHCP administrators, and then people search for DHCP, and there's nothing. Okay, well, there's something, but, but we'll get to this one later. So really, it says I've created two groups. One group is DHCP administrators, another group is DHCP users. But under here, I can't see DHCP administrators or DHCP users here. And people are like, okay, hold on, what's going on? You said you've created it, but I can't see anything. The reason why is because those two groups are local groups. So they are groups that are local groups, and they're local to the DHCP server that you're working on. So what it's just basically doing is trying to achieve role-based administration, so that if you put a user, if you want a user to be able to administer DHCP on this particular server, put them in that group. So if you don't have the groups here, you see DHCP administrators and DHCP users here. So, but what that means is you have 10 DHCP servers in your environment. The groups are local groups. So if you want someone to be DHCP administrator for all those 10 servers, you have to drop them into these local groups all the time. There's no domain group for that. So that's just one other thing to take note of in that regard. Okay, so now that we have that out of the way, let's open our DHCP console, and let's quickly create uh, okay, yeah, I think it's even, here's an interesting thing. It's even have, because yeah, I think it probably still has the old record of what I had before. Okay, let's just delete all these lists. And then go on the over, yeah, anything, so scope, yeah, okay. So we have the 192.168.129.0 scope here. And then, sorry. And then if we go on the, close this, and then if we go on the, here, and I'm going to stop one of these guys and I'm going to start them up. So first of all, let me look in DNS and delete all the older records that I have in DNS for this. So refresh, anything, nothing, and then under here, refresh. So I'll just get rid of all this stuff, get rid of them. So there's none for the client. Okay, so what I'll do is bring this up. So this is DHCP server. So there'll be communication between this client, this Windows 10 client, and this DHCP server. But what I'll do is I'll capture what the communication is on this link here, and I'll also capture what the communication is on this link here. So the reason why I'm capturing this one is I want to see the conversation that this client will be having with the DNS server. Because we'll see, will the client attempt to add the record in DNS for itself? Will the DHCP server attempt to add the record for the client here? If it does, which records do they attempt to add? So I'll stop capture there, and I'll stop capture here because I was doing capturing before. Stop this, start it, and then start capture. There you go. It's coming up. Let's start capture. Yeah, that's what I want to capture, and start capture here. And okay, yeah, I want to capture this, and then I'm just going to filter out DNS traffic. So you can see this one at the top here. So this is the link to the Windows 10 machine, between the Windows 10 machine and the switch. And if I go on this guy, this is the link between the Windows and the DHCP machine and the switch. So let's filter for DNS traffic also. And then let's see what happens when the machine comes fully on and gets a DHCP address from the DHCP server. So at the moment, let's show the scopes that we currently have configured on this. So on the DHCP server, where's the DHCP server? Yeah, let's see what the scope options that we've configured. So we've configured just DNS and router, nothing else. We've not configured or other options that we could configure. We've not configured DNS domain name, which we could, which will help, which we will later. But let's see what's happened here. So here we go. We're having more DNS traffic going through. Let's see anything. Let's go back to DHCP. Let's see if the machine has a DHCP list now. Address list is refresh. Yep, it's got a DHCP list now. So that's good. Anything DNS related yet? Anything? Nothing. And let's go here. Anything? Nothing. Okay, I think I know the reason why. The reason why is I've probably changed the default behavior, which I thought would go away if I. Yep, I have changed the default behavior. So let's cancel all that. Okay. So that's the default behavior. The default behavior is that one. So let's apply that. So enable DNS dynamic update. So this is the default behavior. If you configure DHCP according to default behavior, this is what you get under DNS dynamic update. You have enabled DNS dynamic update according to the setting below. Dynamically update DNS records only if requested by the DHCP client. Okay, so let's go back to just do DHCP release and renew here. So let's go IP config/release and then IP config/renew. Let's just confirm that it's released it from DHCP. Okay, refresh. Yep, it's gone. So let's renew that again. And then let's monitor again for DNS traffic. Aha, now we are seeing some interesting traffic here. So this is the traffic to the Windows 10 client itself. So one of the traffics that we're seeing is after doing a DHCP release and DHCP renew, you can see this traffic here called dynamic update. And what's going on is this is going from the client 192.168.129.10. That's the client. We go under DHCP and refresh this. You can see that's the client 192.168.129.10. And here's the client attempting to talk to the DNS server to do a dynamic update. So all the thing that it's doing previously, if you look at the top, is the first thing it does is it tries to query test.com, which is the domain. The reason why for this one also, just to let you know, so that to make things clearer, is because I've specifically configured the setting that we mentioned earlier, where we said use this DNS suffix. If I've not configured that, this is not gonna even work at all. So it's because under here I specifically said use this DNS suffix. That's why it knows what to query and all that. Okay, so going back to this one, it queries for that name, and if the name doesn't exist, it tries to register it. If the name exists, it tries to modify it. So just take note of those 2 points because that will be important later when we talk about DNS protection. Because it doesn't care, the name. If it checks, does this name exist? If it exists, I try to modify it. If it doesn't exist, I try to add it into DNS. And then after checking, it got the response back to say, hey, there's no such name as the name you're trying to register. Okay, in that case, register it for me, dynamic update. And then it got a refusal and says, no, I'm not going to register it for you from the DA. So the DNS server is like, nope, I'm not going to register it for you. And the reason why the DNS server will not register this machine, know why, is because by default, on Active Directory integrated zones, there's name protection configured. And name protection means it has to authenticate itself. Now let's go on the side of the DHCP server. So that's here. So this guy, we've seen this guy, it did not attempt to update its pointer record. It didn't attempt that at all. If you look at all the traffic, all it attempted to do was to update its A record. And actually, if you dig down and look at what the dynamic update is, and you dig down and see what the update is trying to do, it's trying to update its A and AA records. That's the only thing it's trying to update. It didn't send anything regarding pointer record update. Nothing. So, but let's go back to the DHCP server now and see what's going on there. And then let's go slowly. Let's go up here. Yeah, we also see some DNS dynamic update request here on the DHCP server. So this is DHCP server 192.168.129.3 to the domain controller. First, it does a query. Now look at this. The thing that the DHCP server is trying to update is the pointer record. It's like, can I get an SOA for this reverse zone? And then it replies and says, this is the SOA for this reverse zone. Then it tries to add the record for the client into the pointer zone. And then if I scroll down here, you can see under update here, you can see what it's actually trying to update. So you can see 192.168.129.10, which is the client, and that's the name, IE11win10.test. And let's go back to the domain controller, the DNS server. If I right click here and refresh, so I'll come back to this one. So you see this one here, under pointer zone, you can see that there's a record, right? There's a record for this machine on the pointer zone. But what about under test.com, under the forward lookup zone? There's no record. Because by default, on a Windows machine, the client attempts to update its own pointer record, its own A record, its own host record, and instructs the DHCP server to update its pointer record. Now, where the instruction is, I can show you exactly where that instruction is. So that instruction is under the DHCP packet that goes between them. So that's under boot P. So you can see the DHCP discover, the offer, the release, and the acknowledgement. And under the request is where you find where the client is telling the DHCP server, go ahead and register my pointer record on my behalf. And that is this option here. It's called option 81. So let's bring up Google here and let's go look for option 81. And you see what's mentioned about option 81 is, let's expand this a bit. So the reason why that's important is, you see, the reason why that won't work for a Linux machine. Because on a Windows machine, option 81 is included in their DHCP request. For some Linux machine, option 81 is included, but for some other Linux machine, they will send that, but without option 81. So the DHCP server will go, yep. So then you go there, you won't find any pointer record, any host record. And then for some, you find their pointer records. And then that explains why, how come the DHCP server by default is registering the pointer record for some machines and not registering the pointer record for some machines? Because it's only going to register the pointer records of machines that request it to do so. And the way they do that request is by this option 81.
So option 81 is just for the pointer record and not for the A record, right?
Yes.
Okay.
So you can see that the DHCP, so if I go to, so you can see that the DHCP server didn't attempt to update the A record for the client in the if we bring back the capture that we're doing. So looking back to this, you can see dynamic update is for the pointer zone. If we look up there, there's nothing in there where it's trying to say, I'm looking for test.com, I want to update this. It's not even attempting to do that at all. All it's checking for is for the pointer zone. And then one other thing that we'll mention is, look at the very first thing that he sent. It says dynamic update for this pointer zone. And what am I trying to update? This record in this zone for this name. And the first thing he got back is refused. Okay? Here's the DHCP server by default attempting to update it, and the first attempt to update, it refused. And that is the normal behavior. The very first attempt that the DHCP server makes to update the DNS server with the pointer record of the client will get refused. And then you see it does it again, and then it's successful. Does anyone know what the difference between the first one and the second one is? Here's the difference. Look at this. Here's the difference. Expand additional record. Here we go. tsig. Because now it's including a Kerberos token in this request. The previous one, if I go back to this one that got refused, there's nothing like additional records. It's not sending any additional records with any authentication. So it attempts to do it without authentication, and then it fails. It's refused. And then it attempts to do it this time with its authentication, and then it got a response and says, yep, I'll accept. There's no error. I've done the update.
Okay, so the DHCP server authenticates at the DNS server.
Yeah, it authenticates with what they both commonly trust, which is the domain that they're joined to. So it has to pass, yeah. So it has to pass
Because
token. Carry on.
Oh, sorry, the client isn't joined to the domain, so there's no Kerberos delegation or stuff like that.
Exactly, which is why that failed. So if that's joined to the domain, that will have succeeded, because the client will also try the first time. So actually, I'm not sure why they've designed it this way, but that's the way they've designed it. So let's bring up Microsoft documentation on the 1 minute, where you actually see the record, the first attempt to do the update. Let's see. Okay, yeah, there we go. So let's bring this page up, and I'll add these pages to the recording at the end. Seeing how secure dynamic update works, and then scrolling down. So you see. Let's blow this up, make it bigger. Scroll down. So you see, it says, okay, find authoritative server, result authoritative server's name and IP address, attempt non-secure update, get refused. Now, T-key negotiation, negotiate with security protocol to use. By default in Windows, that's Kerberos. T-key negotiation tells client to use Kerberos authentication protocol. Then it attempts update with the T-signature, which is with this Kerberos token, and then it replies and says it is successful. So that's so the very first attempt it's going to do is non-secure without any authentication, which is always going to fail if you're using an Active Directory integrated zone. So that is just like to set in picture the reason why there may be differences in behaviors when you're talking about DNS dynamic updates.
Okay.
Because
but the client in this case is a DHCP server, right?
Yes.
Okay.
Yeah. But then the client for the pointer record is DHCP server by default. The client for the host record is the client machine itself by default. So Windows machine from Windows 2000, I think, or 2003 upwards will attempt to update their host record by default. And they will instruct the DHCP server to update their pointer record by default, and which is like the option 81 that we talked about. So for example, digging that much down into option 81, because option 81 helps us to understand why it may not work for some Linux machine. Um, Okay, yeah. The DHCP server can be used to register and update pointer and host a record on behalf of the DHCP enabled client. This process requires the use of an additional DHCP option, the client FQDN option, option 81. This option permits the client to provide its fully qualified domain name as well as instructions to the DHCP server on how it would like the server to process DNS dynamic updates, if any, on its behalf. When this option is issued by a qualified DHCP client, so that's DHCP-enabled computer running to Windows 2000 XP and upwards, option 81 is processed and interpreted by DHCP server running server 2003 to determine how the server would do that. So, but then the other thing to note out of this is that when we demonstrate the same thing, the same situation for the Linux machine, you see that the Linux machine sends a DHCP request with no option 81. Therefore, there won't be any attempt to update DHCP on its behalf, which will explain why whenever you have a different mix of Linux in your environment, you see different behaviors when it comes to dynamic updates. So there are ways around that, of course, but let's move on a bit. So that's like we've set the stage for like the normal proper default behavior. This guy attempts to update his own A record. This guy attempts to update the pointer record for this. So we have a Linux machine here. So let's bring the Linux machine up and see what this particular Linux machine, how it's going to behave when we bring that up. So let's bring up the terminal. Uh, First of all, I don't think it's uh, config 80. Yeah, it thinks it has an address, but it doesn't really because we already deleted its list. So sudo dh client release 80. So so it shouldn't have, sorry. Um, um, yeah, I think it's 0 to do that. So 1 minute. So date client release it's 0, and then let's see 1 minute. So I do because it's not released it. It probably is not releasing it because again that's like um Linux behavior for you. You know the reason why. If it's a Windows machine, it will release this address if it doesn't find the DHCP server. I'm sorry, if it doesn't have the list already existing on the DHCP server, but the Linux machine is not releasing it. If I go back to the server here, the DHCP server here, let's log back in here. Um, Refresh. Let's just go back here. Linux machine, start capture of the link, and let's do a release there. So Linux client, where you yeah, let's go G edit. I mean, just leave this one if it's proving difficult, and then we'll just move on. etc. Um, so sudo edit. Let's open that. Let's edit this guy. So it's got this address that I think it's using. Where's that again? Okay. Yeah. Okay. Let's try that again. Okay. That's why. Then let's sudo dh client. Okay. Yeah. That's better. Yeah. Okay. So now here's the Linux machine requesting DHCP address. So if I go DNS, this is the Linux machine. So if I go back to DHCP now and refresh, yep, and there we go. Linux machine has an address already. Now the other thing that I must note is that now I have not added any DNS suffix to that. But let's see what happens in any way. So at least, even though it's not added any DNS suffix, if it replies with option 81, the DHCP server will attempt to do the update. So on the Linux client itself, let's look. Nothing, no attempt to register its name by default. So I must mention that there are different variants of Linux. So, so the one I'm currently testing with is Linux Mint. So you may find out that another one has a totally separate one. But that's just one thing to point out. The main thing, and I wanted to point it out in this one, is that you see different behaviors depending on the different Linux variant that you're using. So there's no attempt at all to update its A record. And one of the reasons why is because it has no DNS suffix. It's like SOA local. So it's looking for the start of authority for local because I think it's in the local domain. Then it doesn't get anything back, of course. But then let's go to the DHCP server and see what the DHCP server attempt to update the pointer record. So this is DHCP server for the Linux client. So let's see anything by the DHCP server to attempt to update the Linux client. I can't see anything. I can't see anything. Okay, why is that? Let's go to DHCP packet, and here's the requests. Expand that, and here we go. Look at the request that has come from this Linux machine. There's no option 81. Exactly. So there's no option 81. So DHCP server is like, yep. So now you go in there in under DNS, you're not going to find anything either for host record or for pointer record. Nothing is going to be there because it's not requested anything. So under host record, refresh, absolutely nothing. Under pointer record, refresh, absolutely nothing for that. Okay, so here's one other thing that let's move a step forward. So what happens in this situation? So again, we know what the default behavior is for the DHCP server. But let me okay, yeah, I'll come back to the other one. So let's go back to the DHCP server. We know what the normal behavior is. Again, on the properties on the DNS, it will only attempt to update the record if the client has requested it. By default, Windows client will request update my pointer record. I'll update my own host record. Linux machines, it varies. Some of them will, some of them won't. So here's one other.
I have a quick question.
Yeah.
So if you have an environment where you both have Linux and Windows clients, it's safe to have that option enabled. Is that correct?
You mean this option?
I mean, it's ideal.
To say always dynamically update. Is that the option you're talking about? This one?
No. Dynamically update DNS records only if requested.
So if you enable this one, the issue that you get is you get people with Linux machines, especially if they have different Linux variants, calling you up saying, I'm unable to get to my machine. Because some of them will find their records registered, while some won't. Especially like their pointer record. So because DHCP, yeah, carry on.
So what's the best practice?
So best practice, I won't say there's like any standard best practice with this. It depends on your environment. And one of the reasons why I won't say there's any standard best practice, you see that now. So think about this situation. Now, DHCP has updated the pointer record, right, for this machine. What happens in a scenario? So DHCP is now the one doing this one. What happens in a scenario if I bring another machine up on this network that also not joined to the domain, but I've also manipulated it that it has the same name as this name, i.e. 11win10.test.co. It has the same name. I've put the same suffix there, and I've said it's a Windows machine, so it's going to do the same normal behavior. So a machine comes up on the network with the same name. What is the DHCP server going to do? What will happen? We already have that set up because actually this other machine here, this one here, is supposed to be called IE11Win endpoint 1, but I've changed the name from IE11Win endpoint 1 to exactly this name. So let's see what happens when this machine comes up. Will DHCP server go, yep, I'm just going to try to update that other option, and then let's see what happens. So let's start that. So the question that you've asked, Vincent, it will develop over time because it varies. In my own environment, if, like for example, like for our research team and stuff like that, they use a lot of different variants of Linux. I usually just go for always dynamically update. So always dynamically update means, hey, if the machine has requested, so actually let's try this. So let's change this from dynamically update DNS record only requested by DHCP client. Let's change it to always dynamically update DNS record, right? And apply that. And then let's go to our Windows 10 machine and let us release the DHCP address. Let's see what happens when we release the DHCP address. Go back to the DHCP server, refresh. The DHCP address is gone. Go back to the DNS server. Anything happened with the record? Refresh. Yep, the record is gone. So whenever you do ipconfig release, it actually so DHCP will not only take out the record in DHCP, it will also remove the record that it has added in DNS. And then of course there's no record in the forward lookup zone. So now, this time around, we've set the option to say always dynamically update. Whether the client requests it or not, go ahead and dynamically update. Now, let's see what this behavior is. So let's, again, filter for DNS traffic. Let's scroll all the way down so we can see what the... so this is the record from the DHCP server when it was removing the record from DNS after I did an ipconfig release. So when it was doing the update, and the way it does that is simple. It just basically goes, it sets the time to live of the record to 0. That's what it does for the update. So if I expand this, so you see time to live 0. So that's how it takes it out of. So the reason why I'm mentioning this thing, I'm not sure we'll get there today, but maybe some later time. When you start seeing like DHCP DNS security, if someone crafts a packet and sends time to live 0 to your DNS server and it's authenticated, it will remove that record because the way it's doing the deletion is it's saying, hey, just set the time to live of this guy to 0. I have rights to this record, which we'll talk about also later. So it's just gone, boom, it's gone. That's that. Okay, so DHCP release renew on this guy. Let's renew DHCP now. And let's see what happens. Will the client, so this is the client itself. Let's do DNS, because that's what we want to check. Does the client attempt to update its own A record? Yeah, it will still try to update its own A record. So you see dynamic update, it will try to do the update, but of course it will be refused because it's not authenticated and it's trying to do it against an Active Directory integrated zone. So it's not by default, that's the way by default it's not gonna work. So it refused. Now let's go to see what the DHCP server is doing in its own way. So DHCP server now and dynamic update. Now look at this. This is interesting. So now the DHCP server is attempting to update both the A record, both the host record. You see, it doesn't care about the forward lookup zone before, but now that we've said always dynamically update, whether the client requests or not. So now it's like, I'm not looking for option 81. I'm going to try to dynamically update this. And now you can see it got this one trying to do the update for the host record, and then down here is trying to do the update for the pointer record. And now my assumption will be, if we go back on the DNS server, under the for lookup zone, if I do a refresh, here we go, the record is there, added by the DHCP server. And now you know, if you go under properties here, under security, and you can see that's the DHCP server there, server 3. So
this was a second Windows machine with the same name.
No. So I'm not yet there. So what I've just done. So the demo that we're just doing now is the demo of changing this setting from only dynamically update if the client requests it to always dynamically update. So that's the demo that we're doing. So in this case, the DHCP server has requested the DNS server to do both the host update and the pointer update. So now, if you set this option, DHCP server will send both host and pointer update request to the DNS server. Whether the client requests it or not, it doesn't care. So that one. And the reason why this one is important for you, because where this one can be a bit tricky for people, is in the way DNS behaves in Windows, is any record, any device, or any user that created a record becomes the owner of that record. So that's one thing where this can become tricky. Where in a situation, let's say the machine is previously joined to the domain, right? And the machine can authenticate itself, and the machine has already created its own A record in DNS. The machine now owns that, because you can see now that DHCP is the one that created that record. DHCP is server 3. And we go under DNS, under the property of that record, you can see that under permissions, the DHCP server has read and write access because he created this record. And it's going to be the same thing for the pointer record. And if I go on the pointer record here, let's refresh this. And there we go. That's the pointer record for this. And you're going to see that server 3 is the one that has this one. So that's where this can start becoming a bit tricky, because now this guy, apart from enterprise admins and DNS admins and administrators, this guy owns this record. So except you want to start putting all your other machines in enterprise admins, basically, or you want to start pushing them in DNS admins, this is the guy that owns this record. So if the client were to be joined to the domain and the client attempts to update this record, it won't be allowed to, because it doesn't have rights to this record. I'm not sure if that's clear. Now, there's a way around that. One way around that is there's a group by default in Active Directory. So the group is called under built-in, or is it under users or under built-in? Yeah, this group here, DnsUpdateProxy group. So this is a built-in group in Active Directory. And look at the description. DNS clients who are permitted to perform dynamic updates on behalf of some other client, such as DHCP servers. So, Vincent, you're asking for best practice. So a best practice would be all your DHCP servers must be a member of this group.
Okay.
Because this group is a built-in group. So any DNS client who is permitted to perform dynamic update on behalf of other clients, such as your DHCP server, add them to this group. Because one of the reasons why this is important is because if this DHCP server 3 were to die completely, and now server 4 is the new DHCP server 4 is the one renewing the leases. Server 4 attempts to update that host record, server 4 won't be able to. You know why? Because it's owned by server 3, right? But
so
now
we need to put in server 4 under DNS update group.
Both server 4 and server 3 need to be in this group. So once they are in this group, what the behavior will now be with this? The behavior will be anybody that's a member of this group, once they are the ones that updated the record, any other member of this group can replace that record. So that means all your DHCP servers. So if server 4 and server 3 are in this group, any records that server 4 creates, server 3 can update. I'm not sure, is that clear? Is that clear or is that confusing?
Yeah.
So that's one thing. So if you're going to be having like multiple DHCP servers, if you don't add them here, you start having records where, for example, if something wants to take out one of your DHCP servers, all of a sudden it owns a lot of records, and no other DHCP server can update that record. But once they are in this group, any members in this group can update any record that any members have created. So just to do that, I'll add my DHCP server 3 here into this group. And okay, server 3, and I'll apply that so that you can update it, so we know it's updating it on behalf of other ones. And then the other thing, the other best practice or the other good practice is under DNS admins. So we'll talk about this when we get to name protection and all that. So the other best practice for DNS admins is create an account, which I've created here. I've called it DHCP DNS Updater. Give it a very complex password, a 76, not 76, a 50 character password, complex password. Give it a complex password, and then configure this account to be the one that your DHCP servers will use to be doing the updates. So what do I mean by that? So let's cancel this. So I have this account called DHCP DNS Updater. This is the account, and I'll just add the description and say account used by DHCP servers to update DNS. So I'll put that there and say that's the account that they'll be using. Give it a really complex password and say okay. And then I'll add this account into DNS admins. If you look at it, every record in DNS on the DNS in the DNS zones, every one of them, DNS admins has permissions to them. Yeah, hello Kafayat, how you doing? So every record in that zone, so DNS admins has record to that. So put that group, that account in DNS, and then under DHCP, all I can do is say under the protocol here. Is it on the protocol under the server? Yeah, let's see. Under the protocol. Yep, under the protocol IPv4. Under advanced, under the properties and under advanced, I can select and add a credential here and say this is the credential that you'll be using when you're registering names. So if I go here and I change this and I say the account is DHCP DNS updater, domain is test, password, I type in the password and I type in the password and I go okay. So now from now on, the DHCP server will not try to use its own computer account to do the update. It will try to use the account. And if I go, and that will be configured across all your other DHCP servers. So that's another thing that you can do with the behavior that I've described, where one of your DHCP server dies, now you're in trouble. So if I go back here and I go again, release this guy, and again, remember the DHCP server would attempt to update both its A and its pointer record, right? So pointer record is gone, refresh, A record is gone. Now let's renew it again. And what should happen is now we're not going to see server 3 under the security. It's the account that you've configured under that for DHCP server to use that we're going to see that has the permissions. So if I come on here and refresh, here's the name again. Go under the name, go under security. Now you see we're not seeing server 3 now. We're seeing the account that I've configured, DHCP DNS updater. So it doesn't matter if server 3 were to die completely, DHCP DNS updater still has access to update this record. Is that clear? So you can read more about that. So you can just search Google for this group, DNS proxy. No, not this kind of DNS proxy. So DNS update proxy. DNSUpdateProxy, and just read about it. They have like some, DNS record ownership. They've got this is a really good documentation that describes this behavior and this issue, where they went into details of, hey, for example, a Windows Server 2008 DHCP server performs dynamic updates. The DHCP server creates the client DNS name and becomes the owner of that name. Now, only that DHCP server can update the DNS record for that client name. The original server fails and the second backup DHCP server comes online. Now, the second DHCP server cannot update the other client's name because it's not the name. So now they've got a group that you can add to that. Yeah, so just go through that documentation whenever you have the chance. So yeah, so let's go forward a bit now. So we've seen the behavior for server. Go back to server 3. Bring up DHCP. This is server 1, server 3. Bring up DHCP and let's go on the DNS. So we've seen the behavior of dynamically update for Windows and for Linux. Always dynamically update. We've seen that also for Linux. So if, for Linux also, let's see that behavior. So let's see if the DHCP server we attempt to update for Linux also, both the A record and the pointer record, if it's set to always update. So let's see. So refresh it. So on that, okay. What do I have open anyway? Okay, here we go. Cancel that. So let's go on the Linux Mint. Hello, Linux Mint. Let's release it. And then let's confirm it released after it's gone. It's taking its time. Yep, it's gone now. And DHCP server release, refresh, Linux Mint is gone. And then if I go back on the Linux and do a renew, and then let's see what's happening on the Linux. So that's the Linux traffic again. Again, you won't see it even attempt to update its own A record. So it's going to be different for different ones. So it's not even going to attempt to do anything like that. So, but let's see what the DHCP server would do on its behalf. Scroll down. So up. So here we go. Start dynamic updates. Yeah. So this is let's go dynamic update response. So that IE10. So you can see it attempts to update the pointer record, but it did not attempt to update the host record. Does anyone know why it didn't attempt to update its host record? Because of the behavior that Sven mentioned at the beginning. Which zone am I going to put it? The server is coming to me. Sorry, the machine is coming to me. Now this one, the Windows machine, the DHCP server has a fully qualified domain name because we've added a suffix to it. Now the Linux machine that's coming now doesn't have a fully qualified domain name because it has .local. So it's like, which zone am I going to put it? Which zone am I going to query? Am I going to query .local zone? So it only attempts to update the pointer record for the Linux machine. So if you remember, when we said only attempt to do this if the client asks you to for the Linux machine, it didn't even attempt at all because the Linux machine didn't have option 81. So, but now that we said, hey, don't care about that, go ahead and do that. Now it's attempting to do that. So my guess would be we won't find an A record for that Linux machine, but we'll find the pointer record. So if we go back here, so under the forward lookup zone, refresh it, nothing. Under the reverse lookup zone, refresh it, and where is that? Nothing. I can't see anything. I'm sure something new came up now. Let's go back to the traffic that we captured. Let's just check what was in that traffic. So that's the request, update request. That's the first one that was refused. Then the update request again. Let's see what's in the update. Now, okay, this is one for Windows 10, not for Linux. Anyone for Linux down here? Anyone for Linux down here? So so basically, this is not done anything. It's not done anything for the Linux machine. So my guess would be that's also tied to because it doesn't have any suffix attached to it. But I would have thought it would still have done the Now, okay. My guess, I've thought it would still have done the pointer record because that's not dependent on the name. Okay, let's do another option here. Let's go to DHCP server. Let's go under properties. So it could be that the Linux is behaving like some of the older Windows clients. So because one of the things I usually struggle with is what's the difference between always dynamically update DNS records, right? So in other words, don't care about whether the DNS client has the DHCP client asks you to update it. Go ahead and update it anyway, or dynamically update DNS record for DHCP clients that do not request update. So what's the difference between these two? Because they both sound the same. Always dynamically update and dynamically update for DHCP clients that do not request update, whether they request it or not. So if I cancel that, let's go properties again, because I want to enable that option, because I think that's what this Linux machine is doing. I want to enable this option and apply that and click OK to that. Again, DHCP server here, 2968 is that last packet. Let's release and renew the address for Linux machine. And let's renew it and let's see. So I think it's behaving like an older client. Any questions so far, by the way? Any question regarding what we've discussed so far? So let's see what's going on. Let's see, attempting anything. Yep, I think it's attempting it now. So let's see what's in the update file. .11 and domain name mint. Yep. So now it's attempting. So again, the lesson to learn from this is if you have Linux machine, you can't assume this is standard behavior. So the second option, always update. Is that still only updating pointer or both? No, it's both A and pointer records in. It's gonna update both A and pointer records. So in this situation, let's see. My guess would be, yeah. So here you go. So it would have attempted to update its A record, but again, because this guy is claiming to be from the domain with zone mint, it's like, let me check for the SOA for domain mint to know where to put that request to. So it's like, of course, there's nothing called domain mint. It failed. So it just basically abandoned trying to update the host record. But then it tries the pointer record update. So it tries that one. That's the pointer record update there. And refused the first time, tried the second time, successful the second time. And then if we go on this one, we'll say the pointer record, I'll guess now. Yeah, and then we have mint here. So one thing that this has brought out is that if you have different Linux machines in your environment, test them. Don't assume that this is the behavior that I've ticked this option to always dynamically update. Therefore, that's going to be the behavior. If they are joined to the domain, you may have better behaviors. If they are Linux machines not joined to the domain, one other thing that people have said online is people have said on Linux machines, people have said what you could do is to add the suffix like we did for Windows for non-domain joined machines. If I go sudo gedit under resolve.conf file, if I go under file system, under resolve.conf file, under etc resolve.conf file, they're like, yeah, just add the domain that you wanted to check there. And I've tried adding that and I still didn't see any change in results. Again, for Linux machine, the behaviors may be different. So what they've said is just add and say domain test.com here and say, sorry, that's not right. Domain test.com and say search test.com, sort of like a similar thing to what we've done for Windows to say that's the suffix and stuff, and save that. And if I close that, and if I do sudo gedit etc slash resolve.conf, yeah, and then if I close this and do sudo dh client release and then renew that again. So actually just releasing it, let's see if it releases the pointer record. So I won't be surprised if it has a different behavior. So I've done a DHCP release. As it releases DHCP address on the DHCP refresh. Yep, so it releases DHCP address. Go back to DNS. As it released that DNS record. Nope. Nope, it's still right there. It's not done anything. It's not removed it at all. DNS record still right there. Security DHCP DNS updater. Yep, it didn't even attempt to do that. So and we can see the reason why. Let's see if we try to trace it back. Did you try the DNS update? Refused. So let's see this one. So because that's set to that's the original one. So I can't even see any. I can't see any request to remove that. Yeah. So okay, let's renew that again. I hope we can just renew that again. Let's see what the DHCP server tries to do for this guy after we renew it again. So I can see it's still trying to look up mint.local, even though I've added the thing that I saw in the instructions online where I had, so you can see it's still looking for mint, even though I've had domain test.com there. So except you fully join it to the domain, don't trust that just adding a text file, just editing that text file will do anything. So yeah, that's the behavior that I saw. Then of course it tries this one, and then the update response. So going back to this guy, it's going to have this, but definitely it's not going to have the other one. But then the other one that I want to test again is, let's look at this one again, is this 3404, right? Let's do a release again. I want to see why the DHCP server is not attempting to remove that pointer record. So let's do, if I renewed the DHCP server, okay, yeah, I've renewed it. So let's release it now. So let's see, 3404. Let's see, is it going to attempt to remove that record? Or is it not attempting to remove that record? And then if it doesn't attempt to remove that record, why? 3404. I'm not seeing it attempting to remove anything. It already released the record here. DHCP is already released the record in DHCP. But there we go. DHCP is not, it's not even attempted to remove this record. And then we go back on the DNS and we refresh this. That record is still there, even though we've released it. So I'm not sure. I'm not sure. Does anyone have an explanation? Sven, any thoughts on why doing that?
Perhaps we should check the security tab.
Yeah, so the security tab is got, yeah. So the other thing is we're not even seeing the packet. So the thing is, if it's security, we're not even seeing the packet even go at all. So it's the DHCP DNS updater that has rights on that. It's not even sending the packet at all.
That's right.
Yeah. So what I would say is when it comes to that, trust the documentation for Windows machines, for Linux machines. Do your own tests to know what the behavior will be in your environment. Do your own tests. Okay.
Perhaps we should look at the release package.
Okay. So
perhaps the client uses a different name of stuff like that.
Let's see. So that's it right there. This one. So DHCP release here. So let's see. You just said, yeah, there's a release packet from me to the DHCP server 11 to 3.
Okay, what's in host name?
Where's the old
option 12?
Option 12, where's down here?
Yes,
Yep,
yes.
it's me.
Okay.
And go down here. It's not even attempting to do anything. But then let's see, is there any difference between this and the one for Windows? Because the one for Windows, we have it up here. So if we see the release for the one for Windows here, yep, this is the one for Windows, I think. Option. So this is a DHCP release. Oh, there's option 53, option 54, client identifier, option 61, option 255. So the pack again, my guess would be again it's implementation of DHCP client, because the packet for this one is for the Windows machine. There's 192.168.129.10. The packet for the release, you're right, is completely different from the one that Linux sent. So this has option 53, 54, 61, and 255. And the one for Linux, it's got options 53, 54, 12, and 255. So so it's so again, Linux, test it. Don't go by the normal stuff. Okay, so we've beaten that horse to death. We know what the normal behavior is. We know that this guy will attempt to update its own pointer record. If we set this one to always update, it will attempt to update both the host and the pointer record. We've understood the concept of the security, that whoever creates the record has rights to it. So we either have to put them in the group, DNSUpdateProxy group. You think after renewal, it's going to update DNS record. Yeah. So the thing, caveat that we're talking about is why it's not, because if we release the DHCP address for the Windows client, after DHCP drops that list, it also updates DNS and deletes that record in DNS, the record that it has added in DNS on behalf of the client. But in this case of the Linux one, it released the list for the Linux machine, but it's not attempted to update DNS, even though the option to say always delete is configured. Yeah, it's not even attempted to say I'm going to remove this record. So the option to say discarding and pointer record when list is deleted is configured there. It's not even attempting to say, hey, I'm going to go ahead and remove this record from here. So it just left it alone. So okay, let's move a step further, because this one that we're going to next is one that confuses a lot of people, which is scavenging. So scavenging does confuse a lot of people because it has all these different parameters that it uses to calculate stuff and all the other kind of stuff. So one other thing that I should mention before scavenging actually is this thing called DHCP name protection. So we've talked about DNS name protection on the DNS side. So DNS name protection is I won't allow you. So again, there's name protection on two sides. There's name protection on the DNS side, and name protection on the DNS side is I won't allow you to create or modify a record except you're authenticated. That's name protection on the DNS side. Now, but there's name protection on the DHCP side. Under this option, you can see it here, DHCP name protection. And name protection on DHCP side, I'll show you what it protects against. So now, remember we have this machine here, i.e. this Windows 10 machine. We've configured the DHCP server. Let me show what the configuration is. We've configured the DHCP server to say, don't care whether the client sent you a request to update or not, go ahead and update both the host and the pointer record. And the behavior that we saw after configuring this is the DHCP server on behalf of the client registered this host record, this pointer record here, because we can see here from security DHCP DNS updater, which is the account it uses. And under the forward lookup zone, it also updates this host record for the client. Yeah. So what we now want to see is, even though we have DNS name protection configured, right? What happens if another machine called IE11 Windows 10 comes online? What will happen? So this is an interesting one. What do you think will happen? So again, remember that now DHCP is the one. So let's draw this in paint. DHCP is now the one. So where's the whiteboard? Yeah, okay, here we go. So DHCP is now the one that updating DNS record, both the host record and pointer record, on behalf of this client. So DHCP is the one doing both. Now, another machine comes online on DHCP, and this machine says, okay, hold on, DHCP, I'm also win client 1. I also have the same suffix that this guy has. This guy has a suffix of test.com. I also have a suffix of test.com. So the normal behavior will be this guy will come online. This guy will also receive address from DHCP, and DHCP will attempt to update both the host and pointer record for this client. But this client guy is a fake. What do you think the behavior will be? Let's see what the behavior will be. You see why DHCP, so why DNS name protection alone is not enough, why you need DHCP name protection. What do you, so Sven, you wanted to say something. What do you think the behavior will be? Do you think DHCP will just go ahead and modify it anyway?
Well, the answer would be easier if the client would be joined to the domain, but...
No, in this behavior, okay, yeah, if the client is joined to the domain, it will be that, because you can't have two clients with the same name.
Yes.
But here's the thing.
Absolutely.
But think about it that way. But if you're a security guy, you can craft packets, right? You can craft packets to contain the information that you want. So what if I have, so DHCP server is not authenticating this client. A machine comes on the domain claiming to have this name. DHCP server doesn't go, yeah, I need to authenticate you. DHCP server just gives you an address. You're joined to the domain or not, it doesn't care. So a security guy, somebody who knows security a lot, was able to craft a packet, take advantage of this scenario, which is exactly the reason why Microsoft has added the DHCP name protection. Because you see what will happen now. So what will happen is we're going to bring up this other client. This other client here is named exactly the way this guy is named. Now, this guy's IP address is 192.168.129.10. So we can see that from the DHCP list is here. So you can see that's the guy there, 192.168.129.10. So let's bring up this other guy. So this guy's address in this scenario will probably be .12. So this guy will have an IP address of 192.168.129.12. But it has the same name as that guy. So let's see what happens. So I'm gonna go stop there and start this guy up. Now if we go, why this guy is starting up? And actually I need to stop this guy and start this guy up too, to make sure that they're both up. So why both of them are starting up? If I go under here, now you can see the current record in DNS is the one for the original machine, 192.168.129.10. And we can see the one for this pointer record is, yeah, here we go. You can begin to see something here. The other client has come online and DHCP has added a pointer record for it, 192.168.129.12. And it has the same host name. Okay, both of them still exist, so no problem. So it's going to use round robin, respond with this one, respond with this one. Okay, no problems. What about the forward lookup zone? Let's refresh that. Oh, look at that. It's updated it with the fake client. That's exactly what the behavior will be if we don't have name protection enabled on the DHCP side. Because now you have DHCP being the one doing all this update for the Windows client. This guy comes on, DHCP doesn't authenticate him and says, I'm also this name and stuff. DHCP gives it an address and DHCP says, definitely I'll register you in DNS. Now, when DHCP goes to register it in DNS, DHCP goes, okay, hold on. There's already a record for Win Client 1. It must be that Win Client 1 has changed his IP address. Therefore, I'm going to go ahead and modify this existing A record. Now, it's going to create two separate pointer records, but it's going to modify the existing A record. So that's the behavior. And you can see why that can be dangerous for you in your environment. When you can have any machine come online claiming to be something, and DHCP will just go ahead and update that on behalf of the client. Doesn't care. And now the other machine has taken over. And it will be the same thing. If I keep switching them between one another, if I fetch this one now, if I go back to, so that's the Windows 8.1 machine. If the original machine comes online, you're just going to go ahead and do the same thing and say, yep, I'll just go ahead and modify the record to this one also. So it's one of the reasons, that is the main, I mean, that's the main reason why you need this option. DHCP name protection. Because if you read the description, it says name protection provides the following capability. The DHCP server will register a and pointer record on behalf of a client. However, if there's a different client already registered with this name, the DHCP update will fail. But if you don't enable this, if there's another client already registered with that name, DHCP will go ahead and modify that name, which is a security risk. It depends on different environments, Vincent, if you want to ask for best practices. If you think you can take that risk, yeah, then go for it. If you think it's a big enough security risk for you, if you have, for whatever reason in your infrastructure, infrastructures are different. For whatever reason, you have important infrastructure that runs on DHCP, you probably want to have this enabled. So let's see, without this enabled, let's see the behavior. With this enabled, let's see the behavior. So let's cancel this. Let's go back to, so we have both Windows 10 and Windows, so both of them are basically the same name. So if I go command prompt, if I go host name here, you see it's exactly the same name. I've named it exactly the same name as the Windows 10 machine. If we go back to the DNS server here, you may find out that it's already updated this. Yeah, you see, because the other one has come online and the other one is like, yeah, I'm also the same name. My IP address is .10. DHCP has just gone. Yeah, I'll just update what I've just done. So now you can see it's .10, right? If I go to this guy and I say to this guy, ipconfig /renew. Look at what the DHCP server is doing. You can see it will just be going up and down like a yo. You just keep going. Gonna go DNS and scroll all the way down and do an ipconfig renew. That's 4413. So go to this one, ipconfig renew, enter. Let's go back to DHCP. What's it doing? You can see dynamic update query, dynamic update response. Go back to DNS. DNS is like, I'm .10. If I refresh this, it will have changed to .12. You see, another machine has taken that. But let's now do that. Let's delete all these ones and let's start with name protection and see what the behavior will be like. So what I'm going to do is I'll just do a release on both of them. So I'll do ipconfig /release. Now if I spell that correctly, release that, and I'll do an ipconfig release on this guy also. So ipconfig /release. So both of them are the list of their addresses. Let's confirm on DHCP lists that, yep, no one's got a list. Let's confirm from DNS records that all the records are gone. About pointer records, see both of them. So for pointer record, it will register dual pointer record, but it will modify the host record. So pointer record, you see both of them have the pointer record here. But if I refresh this, yeah, it's gone. Both of them are gone. So now let's start with the original machine, which is this guy. ipconfig /renew. And what should happen is, again, as we've seen in the normal behavior, it's going to update, but the host and pointer record, DHCP will do that now. So, and then we should see the pointer record here now for .10, and then on the default lookup zone, refresh, we should see the host record now, right? So actually, before I do that, let's enable name protection first. So let's release that, because I'll show you the reason why that can be dangerous. It could be dangerous. So don't watch this and then go home. Sorry, go to work and just go ahead and click on your existing infrastructure and go ahead and click enable name protection, bad things could happen. This is you have to do it with a lot of planning. This is best done out of the gate before you start registering record, because bad things could happen, because DHCP could turn around and start protecting false names. So you may notice that bad things are happening. You're like, this is the original machine. How come I can't update this name? Because DHCP is now protecting him. Exactly. So the behavior I've mentioned now, Kafayat, is if the fake one renew first, and then after it has done that, you now go ahead and click enable name protection. Now the fake one is protected. Now you so yeah, you have to be careful. So don't just go ahead and switch this on at work because it could lead to unexpected issues. So now this one is gone. Yeah.
I have a question about it. What about faking DHCP release package, and afterwards DNS server would release and delete the write record, and afterwards I can send an update package, and afterwards DHCP server would register the real my fake my fake A record, right?
Yeah. So here's the thing. So that's a good point. But we need to understand how DHCP name protection works. You see how it works now in a minute. It uses something called DHCID, which is unique to a machine. So again, all these links that I'm putting there, I'll put them below in the video recording below. So DHCID, and just So DHCID is a resource record stored in DNS that maps name to prevent duplicate registration. The resource record is used by DHCP to store an identifier for a computer, along with other information for the name, such as the A and A record of the computer. In other words, this is a record, this is an ID that is unique to a computer. So it uses unique information for that computer to generate the DHCP. So it's a unique identifier. So except you can fake those identifiers on that particular client that registered it, you won't be able to release that record. DHCP will protect that name unless you can, because it uses unique information from this client to generate this identifier. Except you can fake that, then it's going to do that. So to this one again. So this one, if I go, so I'm sure again that you can find like some serious security guys that will look for ways around that. I'm definitely sure. But one other argument that people can put forward is that even though maybe if people are really desperate enough, they can get around it, but still don't make it easy for them. Make them sweat for it. So going back here, so now I've released this record. Let's go back to DNS. Let's make sure that there's nothing in DNS again. Refresh, nothing in DNS forward, and nothing in DNS reverse. It's all gone. So let's now enable DHCP name protection. So scope, if I refresh this, make sure that there's nothing there. Okay. So on the scope, properties, DNS, configure, enable name protection for this scope, and click OK. Now, when I enable that, you see that automatically it's configured like all these other options, and it's grayed them out. Now I can't change them because once you enable this, it's always going to use dynamic updates. So you can't, it's going to use dynamic update if you do that. Of course, you can disable, if you disable this one completely, this one is gone. So this one is only for dynamic update. So if you configure this, it's always going to use dynamic update, which is why it's grayed out all these guys. Okay, so apply that and okay. So again, on the address list let's refresh. Let's go on the original client and let's go renew. And then again, under here, we should see the packet coming for DHCP update response and stuff like that, like we've seen before. And then shortly under the name server, we should be able to refresh these and we can see it's got this one here. And then we should be able to go under the forward lookup zone and refresh these. And it's got, let's go, nothing. Oh, okay. This may lead to something. It could be something that I think, let's see, standard query, any for this one. Because what I'm thinking is, this guy may already have a cached version because again, remember that once the client already exists in DNS, it's not going to attempt to do that. Because what could happen is it's already found a cached version, it has a cached DNS record, and it's like, no, I'm not going to update this. So which is one of the reasons why you want to do this with care. You don't want to do this anyhow. So it tries that. The thing is, I'm not sure if this is the original one. Dynamic update, refused. Any other dynamic update? Nothing there. Okay, so that's 6401 though. That's from the Win10 client. Oh, sorry, that's from the Win10 client. All we're looking for is the DHCP server. So that's the DHCP server. That's 5069. So again, let's go back to this one. Refresh. Let's go back to this guy. Refresh and okay, let's release this. Make sure it's gone. Go back to this. Refresh. Make sure it's gone. Refresh this. Make sure it's gone. Then go back to the DHCP server. If it's not got IP config / display DNS. Hope it's not got a cached record for. Okay, it's got a cached record for that one, but nothing else. Yeah, that should be okay. So just got a cached record for this guy. So on the DHCP server, so that 5103 is the last packet. So I'll renew this now. 5103 is the last packet. So let's see. That's 5103. Dynamic update here. So it queries that pointer record. Pointer record doesn't exist, so it tries to create the record. Of course, refuse the first time, tries the second time, and tries the second time, and the response successful the second time. Now the other thing, the thing that I'm noticing here though, is that I cannot see any attempt to update the A record. So I can't see any attempt here at all to update the A record. So you can see the attempt. So that's 5103 is the last one. You can see the attempt to update the pointer record, but there's no attempt here at all to update the host record. So if I go under DNS, I'll find the pointer record, but then the host record. Refresh. I can't see any. It's not there because it's not even attempted to update it. If I go under DHCP, and under DHCP, if you look under this one, if I refresh this, yeah, and that's the unique identifier that it's using. So basically, except the machine that is requesting for that update has this unique identifier, it's not gonna update that record. So the machine must have this unique identifier. So it creates a DHC ID. But then the other thing that I'm saying is, why is it not attempting to update the... So hold on. Okay, let's try this. Let's go with this on the... Hold on. I thought I enabled... Oh, okay, look at that. Of course. Did you see that? That's so funny. I thought I enabled this option. Maybe I must have clicked cancel under DNS. Yeah. I thought it was disabled now, right? Configure. That's so strange. Or the DNS. Oh, okay. Under the... So I'm thinking, is it that we not only have to enable it under the scope options, but we must also enable it under the server level. I think that's the implication, is we must not only do it at the scope option. So if I do configure here, is enabled for this scope. I think we may need to enable it for the server option also. So I'll just go ahead and do properties there, DNS. I'll go always dynamically update this one, and enable name protection at the protocol level, not server level. Okay. So then if I go on the properties there, in the DNS, and name protection is enabled at the server level. Okay. So then if I go back to this machine, and let's so let's release it, and then let's go back to DHCP, and let's make sure the list is gone. Let's go back to DNS and see that that doesn't exist before, and this refresh this, that's gone also. So then if I renew that again, so let's look at the last packet from the DHCP server. So let's see, so that's 5332. Okay. 5332 is the last one. So let's see. So I can see. So that's interesting. That's an interesting one. I'm not sure the reason why. So here I can see the update for the update request for the pointer zone, but not for the host record. So maybe what that means is it does. I'm not sure. Again, this is just this is just based on what I'm seeing here, not based on Microsoft documentation. So it could be that I'm doing this completely wrong. So could that be because DHCP name protection only works if you're using DHCP name protection only works for pointer records? In other words, the client has to specifically request the DHCP server to update the A record, otherwise it's not going to update it. So again, that's the behavior that we're seeing now. We'll have to do some more reading on that to try to understand what that behavior is. Okay, so let's move to another one, a step further, to probably the final one for today, which is like the scavenging, DNS scavenging. So that does confuse like a lot of people in terms of record gets deleted. Hold on, like the one that Vincent mentioned, record gets deleted. Hold on, where exactly has this record done? Oh, by the way, before we go any step further, let me quickly explain this with regards to DNS auditing. So DNS auditing is not something that's enabled by default. So DNS gets deleted, added. You're not going to find. You're going to go in event viewer, and you're going to be, you're going to get reports. A DHCP record just got deleted, and you're going to be like, yeah, I'll look in event viewer, and you find nothing. You find absolutely nothing. You have to enable it. So there are two ways to enable it. You can enable it manually, or you can enable it by group policy. So if you're going to enable it on all your DNS servers, of course, the best way to do it is to enable it by group policy. So the policy you have to edit is typically, just use your default domain controller policy. Default domain controller policy that applies to all your domain controllers, which in most environments that's their DNS servers, except you have different standalone DNS servers. So, and the policy that you want to edit is go on the default domain policy on the computer configuration, Windows setting, security setting, audit policy, and it's this one: audit directory service access. And you want to audit, it depends, you want to audit of success or failures. So that's the policy to edit. That will give you DNS auditing. But again, that is this option, just configuring this as enabled auditing, but you've not yet mentioned exactly. So it's enabled success and failure auditing, but exactly why you're auditing, you have to configure that. So to configure that, so then after you've enabled that, you can go, so on this machine, so the command is audit poll /get/category, and if you enter that, so you can see if you have directory service auditing enabled here. So you can see here, having enabled that in group policy, it's success and failure here. So on your DNS servers, if any of that is not set to either success or either failure, or both success and failure, you've not enabled that. You have to enable it either manually, locally, or through group policy. So you have auditing enabled there. Then the next thing you want to do is you want to specify exactly what to audit. So to do this one, you have to use @cedit. So if I go @cedit.msi, and in your environment, depending on we don't have time to go into this one. Depending on how you've configured your DNS server, that determines which partition is going to be stored in the Active Directory schema. So in this case, because it's Active Directory integrated and I've configured it to replicate only to other domain controllers in the same domain. So I've not said replicate it across the forest. If I've said replicate it across the forest, this partition will be different. So if I remove this, if I can go on the connect to, and then I can specify the distinguished name to connect to. So usually if you specify only replicate to, so I can show you the option by I mean. So if I go under this DNS server and under properties, and you can see where, so maybe not the, sorry, under the zone itself, not the server, under the zone. So Active Directory integrated replication, all DNS servers in this domain. So that's going to be different if I've configured that to say replicate to all domain controllers in this forest, or if I've specified this one. So because I've specified this one, it's living in this partition in the Active Directory schema, which is this partition. So I can type that in and say DC equals to domain DNS zones. Then my DC equals to test, DC equals to com, and click OK to that, and then I'm connected to that partition. And then what I can do is for each zone under Microsoft DNS, for each of my zones here, I'll need to go under the properties, under security, and specify exactly what I want to audit. So I've enabled auditing, but what do I want to audit? So under security, I can add, typically you, or probably I can cancel that first, go under advanced, because I'm not giving permissions audit, I'm giving auditing. So if I go under auditing here, then I can add, select the principal. Typically you want to audit everyone. So you had, I want to audit everyone. And what do you want to edit under this DNS zone, test.com? So you have to specify for each zone. So do I want to edit write-up properties? If somebody deletes anything, anything is deleted. So I specify what exactly I want to audit, this object and descendant object. I click OK to that. So again, you have to enable auditing in two places. Enable the policy for auditing, to group policy, and then specify under security, under auditing, exactly what you want to audit, and then apply that. And then from now on, all the DNS event will be recorded under the security logs here. So if I click a refresh here, you'll typically see the source as, so if I scroll, the directory service access. So you typically see the source there. So for example, if I show you an illustration, so this 215607, if I go to DNS now, let's see a record in my test.com, refresh this. Any record I can just quickly delete. And this is my domain controller. I probably don't want to delete that one. This is my DHCP server. So yeah, okay, maybe let's delete server 3. Let's delete server 3. So that time is 2156 now. Delete that. If I go under this one, that's 2156, refresh that, and I'll see this one here. So if I scroll, keep going, 2156, I will see it here. Yep, and there we go, 215642, and it will tell you exactly which record. You can see the object name, DC equals to server 3, DC equals to test, that's the record name, and the person that did it under security ID. If it's a computer that did it, if it's Cav Engine, you see the computer name here. And here's one thing that can throw people, is that it said, what access or what have I done to this object? It said, I've done a write property. Okay, what does it mean by I just deleted the record? But you're telling me I have done right, I've written a property. That is because of the way deletion works, DNS deletion works, it's kind of similar to the way deleting an object works in Active Directory. If you delete an object in Active Directory, the object doesn't get deleted, it gets tombstoned. And it gets tombstoned for 60 days by default. In other words, the machine gets a lot of its attributes deleted off and gets put into tombstone. If you have Active Directory recycle bin enabled, then you see the objects on the Active Directory recycle bin. Or if you open LDAP and search for deleted object, you still see the object. So the object still exists. It just gets put in a tombstone, and then that gets replicated out for other domain controllers to mark that object as deleted and remove the attribute. Then after 60 days, it actually gets cleared up completely. So it's kind of like a similar way. If a DNS object is deleted, it gets DNS tombstoned. What that actually means is this. What that actually means is a property of that DNS object, because now it's an Active Directory object, a property of that DNS object is modified. And which property is that? Let's go under @cedit, which I'm under @cedit here. I'm under the DNS zone that I connected to earlier, and I'm under my test.com zone. If I refresh this, this is the record I deleted. But hold on, it's still here. Server 3 is still here. If I double click on it and let's see, you can see this option here, DNS tombstone equals true. So that's why the auditing is showing me I've only written a property. Like, no, I've not written a property. I've deleted it because for now, all that is done is it's just written a property and changed the property. So in the DNS MMC, I won't be able to see this DNS record, but under @cedit, I can still see it, but the attribute is set. So this is by default for 7 days. And after 7 days, it's going to remove this. So you say, how do I find out, when an object is deleted? How do I trace that? I'll tell you how I trace it. How I'll trace it is I'll go into @cedit and find the object here, because I know the object will be here for the next 7 days, right? So after I find the object, I can see the object here, whether it's been deleted or not. And then what I'll look for is I will look for the time that it was modified. So this object has been deleted, right? If I go under DNS MMC and refresh it, I can't see this object in DNS MMC, but under @cedit, I can see it with modified attributes, right? So what I want to do is I want to look for time that this was modified. So if I scroll down and I keep scrolling down, you can see modified timestamp, because last modification must be the delete if it's been deleted, right? If tombstone is set to true, that must be the last modification. So it says modified timestamp 002, and it gives me the exact time when it was modified. So I go to my event log and look for this time. And then I can see who or what modified this object at this. So that's 21:56:42. Go under this guy and I see 21:56:42. There's only a few events. And you can see the event test administrator on this object did a write. And that's the deletion there. So I'll start from @cedit, look for when it was modified, and then trace it back, use that to trace back to the event log, provided you have auditing enabled. So I'm not sure, Vincent, because that was part of your first questions. Does that help you at all if you want to track deletion?
Yeah, definitely.
Yeah,
of course.
So if I want to track it, start from @cedit, locate the object that's been deleted. It'll be there for 7 days. After 7 days, it doesn't get chucked away. After 7 days, it goes into the Active Directory tombstone. In other words, if you have Active Directory recycle being enabled, after 7 days, you'll find it on that deleted object, or you find it through LDAP. When you're looking for objects have been, you can use LDAP to connect and find objects that have been deleted. So I look for the time that it was modified, and then I go look at that time in the event log, and I can use it, provided I have auditing already enabled, I can use that to trace who or what. If it's a who, I'll find the who here. If it's a what, I'll find the machine name. And by the way, you asked for best practices. I know we can't talk on scavenging today because we are out of time, but one of the best practices regarding scavenging, very important, is only enable scavenging on one of your DNS servers. Don't enable it on all DNS servers. So let only one DNS server in your domain be the one doing the scavenging. so that it's not as if scavenging is happening all across all kinds of DNS servers and you can't track it down. You know in your domain, this is the DNS server that's been assigned to do scavenging, and you know which logs you're looking for if you're suspicious of a record is deleted. So, and that's like Microsoft documentation to only have scavenging enabled on one DNS server. So I hope that's been helpful for you today. There's a lot of things that I was hoping we could cover that we didn't even get close to. I mean, we didn't even touch scavenging at all, at all, and that's a really interesting topic. I'm not sure if we'll do a part 2 next week because we'll carry on with our SCCM one. I'll probably post like any hangouts if we're going to do like a part 2 to this one, maybe discuss scavenging at least, because I know that like that's one of the ones that people find difficult to understand, and it would be good to get that out of the way. So any questions regarding what we've discussed today before we call it a day? Any questions at all?
Is there going to be a part 2?
I will try. No problem. I will try. Next week, I'll probably continue with the SCCM one next week. But I just thought because I won't be doing, I wasn't going to do SCCM this week, so I thought let's do something else. So yeah, but most likely there will be a part 2, at least just to get the scavenging one out of the way, so that we'll make it clear as to how scavenging occurs, and then we'll go from there. Okay, if there are no questions, then we'll call it a day, and then we'll see next time. If there's going to be a part 2, I'll post it on the community page and stuff. Thanks very much, guys.
All right.
Have a wonderful week. Yeah.
So, thanks.
Yeah, hello, Ben. Yeah, bye bye. You say hello to your wife and everyone. Yeah, okay. No problems, guys. No problems, Kafayat. Thanks.
Okay.
Yeah. Bye.
Bye.